Hi everyone, these are our class notes on 9-3 that you'll be taking on the 19th of March. We are going to be graphing quadratic functions, which we also did in 10-4, but we're going to use standard form instead of factored form. So quadratic functions we know in standard form look like the following. We've seen that before. We also know about the graphs and that they're called parabolas, which it says here in this next vocabulary word. We've learned that when this is positive, we're going to have our smiley face, right? Our parabola that opens up, smiley face. And if this is negative, we are going to have our frown face, which will open down. We know that we need to find the vertex. We learned about vertex in 10-4 as well. Vertex is either the highest or lowest point on a parabola, depending on which way it opens. So we're going to find it differently. We're not averaging the intercepts like we did in 10-4. We are going to find the vertex by first doing and using this formula. So for the x part of the vertex, remember it's a point, so xy. First part, we're going to use opposite b over 2a. Negative b means opposite of what your b value is, or you can plug in the negative and then whatever your b value is. If it's positive, that'll be a negative b. If it's a negative, it's going to be a negative and a negative, which becomes a positive b over 2a. To find the second part of the vertex, right, the point, the y piece, in the ordered pair, parentheses, comma, parentheses, we take what we get here and we plug it into the original function. These parabolas, let me see if I can scroll. These parabolas have what's called an axis of symmetry. So the symmetry piece to this, there's a line that passes, a vertical line, excuse me, that passes through the vertex and cuts the parabola into two symmetric parts. So if you fold on that line, all of the points line up. And we can show the axis of symmetry using this here as well, which is similar to part of our vertex work there. All right, I'm going to go to the next slide. So the first thing we're going to do is our steps to graphing. And so the steps are to list A, B, and C, which we know where to find those. Then we're going to find the vertex. We're going to make a table. Once we make the table, we're going to put the vertex in the middle of the table. So it's going to be like the third point in your table, third point down. And then we pick the x values based on what our vertex is. So it depends on what the x value of the vertex is, and then we pick smaller and bigger from there. I'll explain when we get to the examples. Then we're going to plot the points. So we are going to move on to our first example, if I can scroll, which I'm going to then shift to paper instead of my computer. Our first example is the following. I'm going to do everything it said to do. So step one says list A, B, C. Well, this is in y equals ax squared plus bx plus c. So it's clear to me that a is -4. Oops. -4. B is 0. There's nothing, no linear term. And c is also 0. There's no constant. That's part one, step one. Step two, vertex. We find the x-chord using that formula, opposite b over 2a. So we look over here, b is 0, so in the top we put a 0, 2 times a, -4. So we get 0 over -8, which is 0. So the first part is 0. We find the y-coordinate, and it's said on the first slide that we went over, is go back to your original. To find y, plug in what you found for x. For x, we know x is 0. So I'm going to write the original, y equals -4x squared. I'm going to plug in what we just found, -4 times 0 squared. 0 squared is 0. 0 times the -4 is 0. Our vertex is 0, 0. Step 3, make a table. We put the vertex where? We put the vertex in the middle, like where your third point would go. Middle of the table goes your vertex. Then you adjust your points off of that. Pick two numbers that are smaller than 0. Think of your number line. Smaller than 0, -1, -2. Bigger than 0, 1, and 2. If you pick units that are equal distant apart, then the y values here will be the same, and then you have less work to do. If you pick numbers that are equal distance apart, these are 2 units apart, and this is 2 units apart, then these y values will be the same because of the symmetry piece. So you can pick, either plug in 1 or -1, but I'm telling you these values will be the same. You don't have to plug in both. Typically, I like to plug in positives rather than negatives. So I'm going to go ahead and plug in 1. Y equals, where do I plug it in? We always go back to our original, and we've done this several times in class. So y equals -4 times 1 squared. So I get y equals -4 times 1 squared is 1 times 1, which is 1. -4 times 1 is a -4. So across from 1 goes a -4. Because of the symmetry, across from -1, we're also going to put a -4. You can plug it in if you don't believe me. Plug that into the original problem, and you will also get out -4, because a -1 squared means -1 times -1, which is 1. 1 times a -4, a -4. You choose, either plug in -2 or 2, but these y values will be the same. I'm going to show the work for plugging in. Again, where do I go? I go back to the original, but this time for x, I'm plugging in a 2. So I plug in 2 squared. Y equals -4 times 2 squared means 2 times 2, which is 4. 4 times a -4 is a -16. So when I plug in 2, I get out -16. Again, if I were to plug in -2 because of the symmetry, this will also be a -16. So if you create your x values this way, same distance apart, the y values will be the same. Same distance, the y values will be the same. I'm ready to graph my points, and then I'm going to stop at this example, although our notes have 2 examples. So I'm graphing now. I should have had my graph already made. Lots of tick marks needed to get to 16. I need to do -16, so I need a lot of tick marks going down. And I'm going to put a few going up. Let me label that this is the x, this is the y. I should have arrows on my ends here. Okay, plotting the points in my table, moving 2 to the left and down 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2 all the way down here at 16. -1 down 4. 0, 0. 1, -4, and 2, -16. And then I connect these with the curve. Oops, I missed. But you get the point. The curve, our parabolas. This is a frown face because my a value is negative. All right, I hope that is clear. Rewatch if it's not. Bye, everyone.